finally we get to the kinematics that we're really interested in, which is the kinematics of your hap kit. So to remind you, this is what the hap kit looks like, and what I've drawn on the screen is just a very simple kinematic representation of it. And the important variables are as follows. We have drawn the pulley, the motor pulley itself. In some of our documentation, I think we'll call this the drive pulley or the motor drive. In any case, it has a radius r pulley, and we also have the angle theta pulley. And we've defined, you could define as positive whatever you want in terms of what is positive theta or negative theta. I've just defined directions that are convenient so that a positive rotation of the pulley will result in a positive rotation of the next item that it's attached to. In this case, that's the sector. So you can imagine that if this pulley rotates like this, then this is actually going to cause the sector to go this way. Okay, so this larger sector pulley has a radius of r sector, and that is pinned here in the middle. And that doesn't finish our kinematics yet, though. There's actually another step, because what we're really interested in is what's going on up here at the handle. So the person might actually, this is my sideways drawing of fingers grabbing onto the end, a person will be grabbing onto this end point with their fingers, and so what we're really interested in is what is the motion of the handle. And we call it X handle. Even though it's not a perfectly straight movement, it is movement over an arc. So that's why this is drawn as an arc, because the tip of the hap kit right here is going to move in an arc. But X handle represents the length along that arc. And the main reason why we think of it as a change in position rather than a change in angle is that when we write code to render interesting haptic virtual environments that you can feel, it's much easier, especially for beginners, to think about it in terms of translations rather than rotations. Okay, so let's get back to the kinematics of this device. So this would be the first kinematic equation, which just says that the radius times the theta of the pulley equals the radius of the sector times the theta of the sector. And this is just because these two are meshed by the friction drive. And the other equation is that the handle, the position of the handle, is going to be r handle times theta of the sector, because you can see that the rotation of the sector here is going to be the same as the rotation of this handle up here. So if you combine these two equations together and you get this kind of motion that I just animated, you will have X handle equals r handle times r pulley divided by r sector times theta pulley. And so you can see how a change in angle of the motor pulley is going to cause a change in position of the handle. And I'll animate that one more time for you. All right. And if you're designing a haptic device from scratch, you can pick our handle, our pulley, and our sector to be the values that you want to create the relationship that you desire between the angle of the motor and the position of the handle. Your haptic device has already physically been built for you, so you can actually measure these quantities and figure out what this relationship will be. So just a quick example of the real physical haptic paddle, just showing some different positions. You can't really see on here how the pulley is rotating, but in this case, if a pulley rotates a certain amount, then this sector is also going to move a certain amount, and similarly, this handle will also move. So going from this position to this position, the arrows of movement of angles will be as shown. And then you could also keep going and eventually get to this position of the handle. And just quickly to look at the hap kit from the side, we're now actually looking sideways at the hap kit, and this is the friction drive right here. So you can see the pulley here, a rotation of this pulley, theta pulley, is going to cause a rotation about this axis, which now I'll draw this way, of theta sector. Okay. And because the hap kit is a 1 degree of freedom device, These equations, back on the last slide, this equation here is the only kinematic equation that you'll need to get from motor input to motion of the handle.